Kendrick.
Pumps. The main function of the pump, it really does three things. It's going to lift the oil from the oil tank and deliver it to the burner. Okay, we are also going to be delivering the oil at a constant and regulated pressure. With the fuel pump, we know that we have the ability to control what that pressure is. So we have to make sure that we are following the recommendations of the manufacturer of not only the pump, but of the burner itself, what that pressure should be that we should be delivering the oil to the nozzle for. And we are also going to be controlling and making sure that when the burner shuts off, we have a clean cutoff of the fuel. Okay? We don't want to be having any sort of after drip or any sort of issues once the pump shuts off. So the components of the fuel pump is kind of right here in this diagram. Okay, it's really nothing more than a set of gears. And those gears are what provides us with the amount of vacuum, suction that the pump can actually handle, and the amount of pressure that the fuel pump can actually deliver. Okay, so we have a couple of different parts to that burner in that pump. Okay, we have our vacuum gauge connection port. That's at terminal number 1. We have a pressure regulating adjustment screw. Okay, that's the little screw that we use to increase the pressure and decrease the pressure. Okay, we have our pressure gauge connection port and bleeder. We have our pump cover screws. Obviously, those are our Allen keys that we have so that we can get to the strainer. We have a return fuel line port. We have a bypass plug if we are going to be using a two-pipe system. We have our fuel oil delivery port, our capillary tube connection, which is going to connect the pump to the nozzle line. Okay, our oil delivery port, obviously that's where our supply line is going to be connected to. Our pump cover O-ring, and obviously the pump cover. So knowing the construction of the pump and knowing the location of these components is important to understand how to not only how the pump works, but it also tells us where to make our connections and how to adjust things and how to get the air out of the pump when we're servicing it and doing stuff to it. Okay? On your single stage fuel pumps, they can contain one set of fuel pump gears. The pressure regulating valve is what controls the pressure of the oil being discharged to the nozzle. Okay? So we have to make sure that we are following the guidelines of that particular pump so that we have a clean delivery to the nozzle at that set pressure. Okay, inside the body, you're going to have a couple of valves and a couple of pistons, really. That's going to be inside there. So this is what is internal to the pump and what actually regulates the amount of pressure going out to the nozzle. So once the burner is off, the piston inside there is actually in a closed position. It shuts off. Okay? That piston is what is held against the nozzle discharge port. And that is being held there by a spring. It is that little piston that is in there that provides that clean cutoff that we're looking for, so that we're no longer able to deliver any oil to the nozzle, so we're not wasting anything. So what's going on there is once the burner starts, my gears starts to spin. And when those gears spin, I develop pressure inside that pump. And once the pump develops enough pressure, that pressure is going to overcome that spring tension that's inside there. And that is how I'm able to deliver the oil to my nozzle, because that piston actually opens. Okay, everybody follow that so far? So you're looking at it right here. Here's my little adjustment screw that we can use to increase or decrease the pressure. When I'm turning this screw inward, I'm adjusting the spring pressure. I'm making this spring push inward. And when I'm doing so, I'm adding more pressure to that piston, which will then increase my pressure going out to my nozzle. But in order for that to happen, my gears inside have to be spinning to deliver enough pressure to make that piston actually open. So there's a couple of things that can honestly go wrong just with this portion of the pump. Okay, inside there I have a spring. That spring can fail. Okay, maybe because some idiot went out there and over-tightened, turned this screw in just way too much. When that happens, now my nozzle will not be able to deliver the pressure that I'm needing. Why? Because now I have absolutely no spring pressure to counteract what I'm trying to put out. Okay? Can the piston itself get clogged up with dirty oil and gunk and crap? Yeah, that can happen. Okay, and when that happens, usually the little outlet port here that goes out to my nozzle and connects to my nozzle assembly, that's going to get all gunked up. I'm not going to be able to deliver the correct pressure. Okay, which is why I say all the time, when you're doing a service or maintenance, you're always changing the filter. You're going to go in there, you're going to change the strainer or clean the strainer, and you're always going to do the nozzle. If there is some sort of gunk that is inside the pump, the only way we're going to be able to see this problem is by taking your vacuum pressure, seeing what you're getting for a vacuum, and seeing what you're getting for a discharge pressure. Usually, as you guys have seen, when you turn in that screw, the pressure increases. If you go to turn that screw and nothing is happening, that pump is bad. Something internally is inside that pump that is making that pump fail mechanically. That could be the spring, that could be the piston is just jammed up, or there's just gunk inside there. There's nothing you can do about it except take the pump out and put a new one in. Okay, we're not going to sit there and try to dismantle the pump and clean it. Okay? So the pressure regulating screw regulates the spring tension, controlling the pressure of the oil discharge to the nozzle. That's the only part of the pump that we honestly have control of. Everything else that's happening inside the pump is all done through the mechanics and how it's built.
Austin, Brand, can you mute yourself, please?
Everybody muted?
Austin Brand's not muted.
No.
He's getting an echo.
So, the strainer. The strainer is going to sit inside the fuel pump, okay? That little cover that we take off. That cover is really what we call the fuel unit reservoir. Once we get all the air and stuff out of the pump, that entire area fills with oil. Okay, that filters all the incoming oil, and it also helps prevent any sort of contamination from entering the nozzle. So, in my opinion, this guy is really the last line of defense that's going to protect the nozzle and your nozzle line and all that. If that is not maintenanced or cleaned, that's a recipe for disaster. You should always be inspecting that strainer. And every time we take that strainer out, we are to replace the gasket that goes along with it. Okay, the gasket can dry out, it can crack, and is what gives us a good seal for the pump so that we're not sucking in any sort of air when that pump is operating. Okay? You're also going to have a shaft seal on that pump. The shaft seal is what literally holds the oil inside the pump and it's not leaking out every single crevice. Okay? We want to inspect this stuff. It is good practice to take the pump out and inspect the shaft. Make sure the shaft is not like all chipped or have any signs of wear or anything like that. You should at least look at this stuff to make sure that at least the pump is still showing signs of good condition. Okay? A solid shaft extending through the pump housing, that's your shaft seal. That's what connects the shaft to your coupler and your burner motor. Okay? When we are thinking about the pump, we have to also make sure that the pump has the same RPMs as the burner motor. If my burner motor is at 3450 RPMs, I cannot put in an oil pump that is rated for only 1725. I'm going to burn the gears out. I'm going to ruin the shaft seal. I'm going to have oil leaks. Okay? Your fuel pumps have a rating on them. Just look at the sticker that's on the fuel pump. It has a rating on it, 3450 RPMs. Make sure you match them. Common problem you will run into in the field, guys, is mismatched RPMs. Okay? Look at what's going on. Okay,
Does
the
the
shafts.
RPM of the blower motor affect the fuel pump?
Yep. Okay, if you have a mismatched RPM, say like you have a 3450 rated burner motor, okay, which means it's operating at 3450 RPMs per minute, and you put in a 1725 rated fuel pump, that fuel pump is not rated to handle that many RPMs. You're going to burn out the gears.
But I'm saying about
pump.
the blower motor. The blower motor runs at a different RPM. So would that affect something?
Absolutely. So if you have a 1725 RPM burner motor and you put in a 3450 rated fuel pump. What really controls the amount of oil delivery, really, to the fuel pump? What's really controlling it?
The burner motor's couple.
The burner motor. Okay? The burner motor is what's spinning the shaft in the fuel pump, right?
Mm-hmm.
So if I have a 1725 RPM motor and I put in a 3450 rated pump, my fuel pump is not spinning at its full RPMs that it's rated for. So therefore my vacuum and my pressure that I'm able to achieve is not going to be there because the gears inside that pump are just simply not spinning fast enough.
He had asked about the blower motor's RPM.
Yeah, I'm talking about the blower motor, because the blower motor RPM,
not the burner,
is different. Yeah, I'm not talking about the burner.
The blower motor, no. Oh, sorry. The blower motor has absolutely nothing to do with the operation of the burner and the fuel pump. The blower motor, all that is doing is delivering the amount of air needed to heat the space.
Mm-hmm.
Okay? So that I have the correct temperature rise across my combustion chamber and heat exchanger. Okay? That's all that's doing.
Okay.
Okay? Just so that everybody's understanding that. Your burner motor and blower motor are completely different entities. Okay? One doesn't affect the other.
It's still possible to show up, though, at a place where somebody put in a blower motor that is not pushing enough CFMs, correct?
Right. Okay. Absolutely. I mean, if you have a burner motor that's not operating at the correct RPMs, your air is going to be either too fast or too slow. Okay, so when we're dealing with air temperatures across the furnace, yeah, you're going to want to take a temperature rise across and see what your delta T is to see what it's within the specifications of that furnace. Okay, some furnaces have a temperature rise of 100 degrees. Okay, what does that mean? That means is that when I'm taking a temperature rise from my return to my supply, I should have a 100 degree temperature difference across the two. If I don't have that, I have to look into my burner motor. Maybe my burner motor is just not at the correct RPMs or the correct speed. Okay, which is now where you'll actually maybe change the fan speed from maybe low speed to high speed or medium speed or whatever the hell it's constructed for. Okay, you're going to want to look into ductwork if you have issues like that. Dirty air filters, dirty blower wheel. You know, maybe a closed off air damper in the supply duct or something like that. That could affect the amount of temperature rise across the furnace. Okay, but the burner motor, all that's doing is spinning the fuel pump. And if those two are not correct, I'm not going to be able to deliver the correct amount of pressure, and I'm not going to be able to have the correct suction or vacuum. That could be either too high or too low if they're not matched correctly. Okay? So the shaft seal on your fuel pumps, that is what provides and prevents the oil that is sitting inside the fuel pump itself from leaking out all over the burner housing and all over the furnace and all over the person's floor. Okay? If I put in a pump and I somehow manage to reverse the rotation on a fuel pump, okay, because sometimes people do crazy things and they put in burners that really don't match the furnace, and they accidentally wire it for counterclockwise instead of clockwise, I can actually ruin the shaft seal. I can ruin the gears inside the pump. And when that happens, now I have oil leaking all over the place. And that's just another recipe for disaster. Okay, so you have to make sure, guys, that you have your fuel pump, your burner motor, all in the correct position and at the same RPMs. That's really, really important to remember. Okay? Because without that shaft seal, guys, you are not going to be able to even lubricate the bearings and the gears that are inside that pump. And that pump is actually going to seize on you.
Mr. Saccavino.
Can you hear me?
Can you hear me?
I can.
Okay. With most of the pumps being preset at about 100 psi, what is the minimum psi that the nozzles need for proper atomization of the oil?
Most manufacturers, it's 100 psi. Minimum.
Okay.
Yeah. Anything lower than that, you're going to have failed ignition, a smoky flame. It's going to rumble on you. It's going to do all sorts of crazy stuff. But minimum, most nozzles are rated at 100 psi. Okay, so your operation of your single-stage fuel pump. Your single-stage fuel pumps is what's going to produce both the pressure and the vacuum. Okay, pressure is the force created by the meshing of the gears inside there, and obviously we measure that in pounds per square inch. Everybody has had the opportunity to at least take fuel pressure and see what you're dealing with. Your vacuum is always going to be measured in inches of mercury. Okay, so we remember what our rule of thumbs are for vacuum, correct? 1 inch for every foot of lift. 1 inch for every 10 feet of horizontal run, right? And roughly about a ½ inch or so for a oil filter.
Then
check
2 inches
valves.
for check valves.
Check valves is what?
2 inches, right?
2 inches, right? 2 to 3 inches, right? Or 2 to 4 inches, right? So when we are looking into what type of fuel pump we are going to need, whether it's a single-stage pump or a two-stage pump, we have to look at the amount of vacuum that the pump can handle. Okay? I want to make sure that my pump is rated and is able to handle the amount of suction that this thing is going to have to overcome. Okay, which is why we want to try to eliminate really long oil runs. I mean, like where we're talking like the oil tank is on the other side of the basement and the burner's like on the other side. We don't want to have oil lines that have to run 50 feet. We want to try to keep them as short and as straight as we possibly can. Because any bends or anything like that that we do the oil line, that it raises your vacuum. And if I have a too high of a vacuum, now I can start burning out the gears, seizing my oil pump, so on and so forth. Okay, so here's an example here. We have 4 feet of lift from an underground tank plus 10 feet of oil line run to the burner, and obviously we add in the oil filter. Our vacuum is around 5.5 inches. Okay, vacuum gauges for a single stage pump, your acceptable is anywhere between 5 and 6 inches of vacuum is an acceptable range for a single stage pump. Anything higher than that, you're going to want to go to a 2-stage pump. Okay? So when the motor turns the pump shaft, oil enters the strainer chamber through the intake port, either by gravity or by the vacuum developed from the intake side of the pump. And as those gears rotate, the teeth actually squeeze the oil and then discharge it out the pressure side through that pressure regulating valve. Okay? So the pressure regulating screw on the regulating valve controls that spring tension, which determines the pressure at which the oil will be forced out the piston. And then obviously through your nozzle port. Okay? This pressure is about 80 to 95% of the operating pressure. Okay, so the spring pressure and that spring tension is really kind of critical to really get the correct pressure that we're actually looking for. Okay, and again, minimum factory settings for most of our pumps is 100 psi. But we also want to follow whatever the burner manufacturer sets the operation of that burner for. Okay, the minimum, again guys, that's a big word there, minimum is 100 psi. We really don't go any lower than that. We can go higher depending on the burner specifications. Okay, so you have to look at your model number on the burner, look at the nameplate, and see what the rating is for that particular piece of equipment and set it accordingly. Okay? Now, when that pump is spinning, it only knows one thing. It knows that it has to deliver oil. It doesn't know necessarily how much oil to deliver. It just knows, hey, okay, I'm on, I have to deliver oil to the nozzle. But that pump can literally deliver 5 to about 20 times the amount of oil that is required for the nozzle. So what the hell do I do with the rest of it? It regulates, right, through that pressure regulating valve. It only knows that, hey, I got to push out 100 psi. It's going to shoot out whatever it needs at 100 psi. So the excess oil that's inside that pump gets to churn around. It churns around inside that reservoir, in that strainer. And it'll only pass through that oil as the gears turn it through. Okay? So, your bypassed oil that's going on in there is going to go through that regulating valve, and it's going to churn around, and it's going to sit there and keep churning. Any of the excess oil is no longer under the pressure. That's going to be pushed out. So some of that oil is going to be used to lubricate the gears. It's going to be used to lubricate the shaft seal so that it doesn't dry out. Okay, from the excess oil to the return of the chamber, the bypass plug located between the pump and the strainer is not installed when you are doing a single pipe system. That's important to understand and know. The bypass plug is never put in a pump when you have a one pipe system or a single stage pump. If you are not sure, take the pump out. Look to see if the bypass plug is installed.
Other than
If it is, if the bypass plug is installed, guys, you're going to have oil leakage. It's going to be dripping out everywhere because there's just too much oil, and it's going to find a place. Chances are the shaft seal is going to rupture because there's just too much pressure inside the pump if that bypass plug is inserted on this type of pump.
Other than cost, is there anything bad about putting a two-stage pump in when when the system only has 4 or 5 inches of vacuum?
Nope.
I mean, I know it's overkill, but there's nothing wrong with it?
Nope, nothing wrong with it. Most mechanics, and what we do is we put in a two-stage pump. You know, they're beefier and they're able to handle more. And it also compensates for any sort of additional stuff that may come down the road, you know, later on in life. You know, like someone puts on an addition or something like that where the oil tank has to be moved or what have you. The two-stage pump is able to handle more of a vacuum. So it doesn't really hurt. When you're going to deal with a lot of this stuff is really where the location of the oil tank is. Your oil tank has to be either above the burner or kind of like on the same level as the burner in order to really have a single stage pump. And if the burner and the oil tank are within close proximity of each other, like 10 feet. Anything other than that, where the burner is actually above the oil tank, like maybe like the oil tank is in a basement and the burner is up like on the 2nd or 3rd floor of a building, then you're going to want to use a two-stage pump because now you have a greater lift to deliver the oil. Okay? So if there is no return line on a single-stage pump, the high-pressure oil would be forced into the front seal chamber, and that will rupture the seal. You're going to have oil all over the place. Okay, most of our shaft seals can only handle around 10 psi of pressure before they rupture. So that's why we never put in the bypass plug, because all we're doing is just loading up that chamber with so much oil, and it builds up enough pressure, and it ruptures the shaft seal. Okay, your bypass plug is only going to be installed when you have a two-pipe system where you have a supply and a return line. Okay, the pressure regulating valve, they can be adjusted anywhere between 100 and 200 psi. 200 psi is really pushing it. You really do not want to go any higher. In most cases, probably 170, I would probably want to say, is probably the highest pressure you would ever really want to push a pump. At 200 psi, you're just putting the gears through just too much, and they can actually break, and then you'll just lose the pressure and the prime, and you're just going to have to replace the pump. Normal pressure settings on your high-pressure burners is around 100 psi, but again, most of our burners, especially our high-pressure burners, they're going up to 140, 150 psi. So you're always going to look at the manufacturer specifications for that burner and set the pump to that pressure. Okay. On the burner shutdown, the spring tension against that pressure rating piston will cause the piston to close, shutting off your oil discharge to the nozzle at approximately about 20% below the operating pressure. So what we're looking for there is to make sure that we have a clean cutoff. When these pumps shut off, we do not want them to lose the pressure that we just built up. So for example here, we have a 100 psi pump. When that guy shuts off, my pressure should be around 80 psi. It'll probably drop a little bit and hold steady. If it continues to drop, you have a bad cutoff. That piston inside there did not shut. So guys that have told you differently, that it's perfectly okay for a pump to lose its pressure, is a crock of shit. When that pump shuts off, it should not lose pressure. Okay? We lose about 20%. We lose about 20% of the pressure that's in there. That's perfectly acceptable. Anything more than that, you have a bad cutoff.
Hey, we have a furnace over in York that has a pressure gauge kind of permanently attached. And when it shuts off, it goes to 0. Is it because of where it's attached to the pump? Is there a part on the pump that you can attach it to that would drop to 0, even though the pump itself is still maintaining that 80%?
I don't know. I would have to look at where the gauge is actually located.
I think they actually told us that it has. We figured out that it has a bad shutoff valve.
Yep. Bad cutoff. Yep.
Bad cutoff valve is why that pressure drops every time we turn that unit off.
Yep.
Okay. Because that's it drops
pump needs to be
immediately
replaced.
to 0.
Yeah, that pump needs to be replaced. The cutoff, the piston inside that pump isn't closing, and you're just losing the pressure that was just built up inside that pump.
I think they call that a learning tool. When we figured that out, we were like, wait, why is this not working?
Yep. And every time you have a system that has a bad cutoff, every time you go to fire it off, you got to bleed the pump so that you can get the prime again. That's the purpose of the cutoff, is that, well, okay, if I'm maintaining pressure inside there, it's telling me that my pump is still full of oil. There's no air. There's nothing in there. It's shut. So when that pump starts to spin again, I can go right up to 100 psi and deliver my oil without a problem. I'm losing the prime. I'm losing all the oil pressure that I just built up. That's not a good thing. That pump needs to be replaced. Okay? But really what we're looking for, I mean, there's different types of furnaces out there. There's different types of pumps. They all have different cutoffs. Okay? There's some pumps out there that say, okay, it's 30% cutoff rating. Okay, so it's at 100 psi. Okay, it's going to lose pressure. It's going to shut off at 70 psi, and it's good. But what we're looking for is anytime we're checking our pumps is we want to make sure that the pump has pressure and that it holds once the pump shuts off. That's the really important thing that we're looking for. If it continues to drop, no, that pump needs to be replaced. You got to have a good cutoff, otherwise you're just going to have issues along the way. Okay, with one pipe systems, most of the oil heat systems today require only a suction line to deliver the oil from the tank to the burner. Okay, obviously our supply line, that is our one pipe system. Okay, older single style fuel units should be piped only as a one pipe, where oil can only flow to the unit through gravity conditions. Okay, gravity conditions means where it's just simply the weight of the oil that's in the oil tank just pushing its way down the fuel line to the pump. Okay. When we want to use this, we do not want to exceed really 6 inches of vacuum when we're dealing with a one pipe system. That's really the maximum amount of vacuum these types of systems can really handle. Anything more than that, you're going to start burning out the gears and just having issues all the time. You're going to have constant callbacks where this furnace is just constantly either intermittent issues, intermittent ignition problems, all sorts of crazy crap. It's just simply due to the fact that the pump just cannot handle the vacuum that's being delivered to it. Okay, if we have more than a 6-inch vacuum, you're going to go to a 2-pipe system. Okay, you can use a single-stage fuel pump if you have one on your truck and you don't have a 2-stage. You can put one in, but what you're going to do is you're going to install a return line. You're going to install the bypass plug in it. And by doing so, you have now converted that 1-pipe system to a 2-pipe system. That pump can now handle a little bit more vacuum. Okay? You're going to do a lot of this stuff when you're doing the overall inspection of your setup. You're going to look at where the oil tank is. You're going to look at the fuel line. Do a quick measurement of the fuel line. Am I within my range to handle this certain vacuum? If not, put a 2-pipe in. You know, it takes you maybe 10-15 minutes to do it. Sometimes that's all you need. You know, you may not necessarily have to kind of go to a 2-stage pump. I mean, sometimes all it is just the vacuum. This is what's just causing a lot of our issues. Okay? If a single-stage fuel unit 2-pipe system has an operated intake vacuum of 10 inches, you can run into unstable flame conditions where you might have that intermittent ignition. You know, like where it'll fire off on this one time, and then on the next call of heat, it locks out. You go down there and you reset the button, it fires off on you. Okay? Real pain in the butt type of service call where it works and then it doesn't work. And then when you go there, it works. Sometimes all it is just the fuel delivery. You have a lot of carboned up firing assemblies. You take out the nozzle assembly and the entire flame retention head is just all sooted up. The nozzle is black. The electrodes are just all garbage. Okay? That's just poor delivery of the oil. Atomization, just not burning properly. Okay? You can have what's called an afterfire. When it shuts off, you see a little flame kind of still sitting in the chamber. That's not a good thing. When my burner shuts off, I don't want to see any fire sitting in the chamber still. That's after drip. Okay? And obviously when it turns off, you're going to have a noisy flame. It's going to sound like hell. Really loud. It's going to rumble on you. May have smoke coming out of every crevice of that boiler or furnace, whatever it is that you're working on. Okay? If we do have an excessive vacuum on there, and we're saying more than 10 inches, you're going to shorten the life of that fuel pump. The gears are just going to wear out, and it's just not going to be able to work. Okay? If you cannot achieve, or if you have more than a 10 inch of vacuum, you definitely have to go to a 2-stage. You can't go any more than that. Okay? You have to go to a 2-stage pump, or install a booster pump in the oil line. Okay? 2-stage pumps uses 2 sets of gears inside there. Okay, the first set of gears is what actually purges all the air out of the pump and supplies the flow of oil to the second stage of gears, which is what actually does all the pressurization of the oil to the nozzle. So in a 2-pipe system with a 2-stage fuel pump, it's not advisable that you go any higher than 17 inches of vacuum. Now, if you really think about that, 17 inches of vacuum, that's a lot. Okay, so think about your fuel delivery system, right? 10 feet of every horizontal run, that's 1 inch. right? So what? You can probably go, what, 70 feet of horizontal run, roughly? And a two-stage pump would be able to handle it.
But I thought the one-stage pump was only supposed to support like 10 inches of vacuum. So why is this saying 6?
Saying 6.
Yeah, didn't you just say a single stage?
No, you want on a single stage pump, you don't want to go any higher than 10. That's like the maximum you can go. If you have more than that, you have to go to a two-stage, and you can't go any higher than 17.
Okay.
Okay. They say recommended. I mean, it's recommended that you don't go any higher than like 5 or 6 inches. But to push it to its maximum, you can go to 10 on a single stage pump, and it still will work. But you're kind of pushing that threshold where you're going to start having problems. Which is why it's really common in a lot of cases. The single stage pumps really are kind of not used as much as your two stage, because they're actually able to handle up to almost 17 inches of vacuum. So they're pretty beefy, and they can pretty much get the job done with little issue.
Yeah, maybe I heard it wrong or I read it wrong, but I think the previous slide said something about 6 inches of vacuum, but the one stage was supposed to be 10 inches, but the previous slide said anything more than 6 inches, you go to the two-stage. But the two-stage is supposed to be 15 inches.
Right. You understand what I'm saying, right?
Yeah, I do. I'm just kind of...
Most manufacturers, okay, we'll try to clarify it. With most manufacturers on a single-stage pump, they say recommended that you do not exceed 5 or 6 inches of vacuum on a single-stage pump.
Mm-hmm.
But in the real world, they can handle up to about 10 inches of vacuum. Okay? Anything more than that, you're going to jump to a two-stage pump, two-pipe system.
Gotcha.
Because now you're able to handle more than that 10 inches. Okay? And in those type of systems, with a two-stage, two-pipe system, you can go as high as about 17 inches of vacuum.
Gotcha.
Okay?
Yeah, good. But along that same thing, though, is, and we've run into this in the past, what we are learning for the real world, which is really the practical stuff that we need to keep in mind, differs from what shows up on quizzes and tests.
Yeah, I know.
What do we need to keep in our head to get through Porter and Chester's tests with those numbers?
Whatever is in your NORA chapters is probably where those questions came from. Just a little. Okay. So those are the answers that they're most likely. Yeah. Okay. So that's probably where they're going to get those answers from. Okay. Just so everybody knows, because I know how important everybody loves quizzes, and me personally, I don't give a flying rat's ass about quizzes. I'm more important about what you can do in the field, because that's really what your boss cares about. Theory is theory. Okay? So, if you have a problem with a fuel system or a fuel pump, and you're actually even exceeding 17 inches of vacuum on a two-stage, two-pipe system, the only other remedy that you can honestly do to get through this problem is to install a booster pump. Okay? Those are going to be installed in line with the fuel pump, well, the oil tank, in between the oil tank and the fuel pump. Okay? Basically, all that's going to do is just adds a little bit more flow to deliver it to the fuel pump, and that will lower the vacuum that's being delivered to the fuel pump. It kind of takes the strain off of the gears on that pump. I mean, if you think about it, how big is a fuel pump? They're actually kind of small if you really think about it, you know. But they do a lot of work. Okay.
Does it matter if it's installed before or after the filter?
You're probably going to want to put it after the filter. You know, just to kind of make sure that you have clean oil going through the pump itself. That's most likely where you're going to have it put in. So you're going to want to make sure, again, that you have adequate fuel supply. Okay, these are usually capable of lifting our oil up to about 15 feet and supplying the oil about 35 feet above the pump. So they can actually help a lot if you have extreme vacuum issues. Okay, it is really advisable that when you are doing a pump test, that you take a vacuum reading, not just a pressure reading. Do them both to see what you're dealing with. That gives you a true understanding of what that pump is going through and if it's actually capable of handling the oil delivery. Okay? In a one-pipe system, when a pump runs out of oil or picks up air due to your high vacuum or obviously a leak or a break in the oil line, the air has to be bled from that fuel unit in the line after the tank is filled and the supply line has actually been repaired. Not only, guys, do we have to make sure that we have a gasket on our fuel pump and we have to make sure that our Allen keys and everything are tight, we have to look at the flares on our fuel pump, our fuel connections. We can have a oil line that's connected but not showing any signs of leak, but we can have a cracked flare on our copper that will be sucking in air. And if that's happening, I'm going to have pulsation with my flame. I'm going to have that change in flame conditions. I'm not going to be able to get rid of all of the air in my fuel pump. When you go to bleed that fuel pump, you should have a solid stream of oil, clear oil coming out of it. If I'm having a constant issue where I'm getting air bubbles and like a foamy like substance coming out of my fuel pump, I have air leaking somewhere into that fuel pump. I have to find the problem. That's really important in order to have a clean delivery of oil to that nozzle. Okay? So you want to look at that stuff. What's a sign of excess of nozzle drip? What do you think is a sign of that, of a nozzle drip, when you take the electrode assembly out? What do you think you're going to look for?
You're going to have oil in your chamber.
Okay, so you're going to take a flashlight. You're going to look down the air tube. When you look down the air tube, should I have oil residue in the air tube? No.
You shouldn't.
No, you shouldn't. When I look down the air tube, should my flame retention head have like a oily, shiny residue to it?
No.
No, it should be dry, right? Because after all, the flame is sitting on the flame retention head, correct?
Huh?
So it should be dry. What about the nozzle itself? You take that nozzle assembly out and you look at the nozzle head itself.
Should be clean.
It should be clean, right? It shouldn't have any black residue on it. It shouldn't have any sort of like burn marks on it, right? It should be in pristine condition, right?
Yep.
So if I take that nozzle assembly out and I look down that air tube, I see oil residue, almost like it's like the oil is kind of like pushing back down the air tube. That's nozzle drip. That's a bad thing. Something's going on. You have an air leak.
Don't you get increased soot throughout the chamber and on the electrodes and the tip as well?
Yep. So there's a lot of characteristics that we should be looking for when we're doing a service on these things. Okay? So you have something going on there. You have excessive dripping at the nozzle after the burner shuts off, which means that it's still hot. You're burning off oil that's dripping out of the nozzle. That's a bad cutoff. That's a bad pump. We got something going on. We have to fix that, which means we are going to be disconnecting our oil line from the pump and looking at the flare connections. We're going to see whether or not there's something inside the fuel line itself that could be maybe possibly obstructing my oil flow. Okay? So there's a lot to just a fuel pump itself, guys. We have to really make sure that this guy is intact and making sure it's doing what it's exactly doing. If I have a clogged oil line, what's my vacuum going to be? Is it going to be high or low?
Oh.
It's going to be low. No, sorry, it's going to be high.
Your vacuum?
Your vacuum. If you have a clogged oil line, what's my vacuum going to be? Is it going to be high or low?
It's going to be trying to suck harder and harder.
Yep.
Yeah.
So your vacuum is going to be high, right?
But your pressure is going to be lower.
And your pressure is going to be lower. You're not going to be able to even achieve the pressure that you're even looking for. So in other words, your vacuum and pressure kind of coincide with each other, huh? I got to have the proper amount of vacuum to my pump in order to achieve my outlet pressure that I'm trying to get to. Okay? So uneven or fluctuating pressure on your pump can cause several flame pulsations. Okay? And what we mean by pulsations, when I put my pressure gauge on there, the needle is kind of fluctuating. It's bouncing all over the place. Okay? That's an indication of a possible clogged filter or strainer. You're going to have possible air leaks somewhere, okay, caused by your strainer chamber, a cover or a defective strainer, your chamber gasket, air leaks in the suction line, or excessive intake vacuum, or a slipping pump coupler. So when I take a pressure reading on my pump, my gauge should be relatively steady, huh? It shouldn't be bouncing all over the place. If it is, I'm going to want to look. I'm going to shut that guy down. I'm going to look at those areas. But notice what it's saying here, guys. Clogged air or a slipping pump coupler, which means my two ends of my coupler are slipping and I'm not generating enough RPMs to push the oil through. Defective pump coupler. So you're going to want to look. You got to see this stuff. Sometimes all you got to do is turn it on and simply listen to the operation of that furnace or boiler. And sometimes it kind of leads you right to the problem. By now we have all turned on equipment and have heard what a furnace should sound like. So by knowing that, and if you hear anything other than that normal rumble that we hear, that should be an indication of a problem. And it should be a red flag for everybody saying, oh, nope, something is not right here. You have the tools to fix it. You have the knowledge now to fix the problem. Okay, if you have a fuel pump operating at least 100 psi and can't be obtained for some reason, I'm turning that screw in, but it's not changing. You have the following problems right there, guys. You have your pump gears. They're worn. Okay, they're maybe broken. The nozzle capacity is beyond the pump capacity. Some idiot in there just put the wrong nozzle in. Just can't handle it. Your burner motor is not up to the correct speed. There you go. You're mismatched. Burner motor, pump. Okay, a loose shaft coupling. Okay, again, defective pump coupler. Okay, or simply due to the fact that the pressure regulating valve inside the pump is just defective. Maybe the spring inside there is just broken. So we got to look at least those areas to figure out how come I can't raise or I can't lower my pressure. But probably 95% of the time, if you have that issue, it's not going to be that the motor is the wrong RPMs. It's probably going to be most likely due to the fact is that the pump itself, the gears inside there are just worn and broken. And it just can't do it. The other 5% of the time may be a defective pump coupler or a mismatched burner motor. Okay, if you have a problem with your vacuum, and that is below the calculated operating vacuum, you are going to be looking at to make sure that you don't have a clogged pump strainer. You're going to, again, make sure that you don't have any air leaks in your suction line or your suction line fittings. You're going to make sure that the suction line strainer chamber, cover plate, and gasket are actually there. Yeah. Okay. I've seen this happen on a couple of occasions where the technician before me put a brand new strainer in, but never put the gasket on. Really.
Wouldn't this also be affected by a pretty full plugged up filter?
Yep, it can. Okay. Other contributing factors, again, you could have a partially clogged oil line simply due to a fact of that maybe someone didn't change the oil filter like they were supposed to. Okay. So with vacuum, that's our ability to suck the oil from the tank to the pump. If I can't achieve the correct vacuum, I'm going to be looking into my oil line. I'm going to do a quick calculation of my line size, how many feet up I'm going, how many feet of horizontal run I'm going, my oil filter. Is there any check valves in my fuel line? And I'm going to do a quick calculation of what I should be looking for a vacuum. And if I still have a problem where it's below, okay, yeah, I'm going to go after this stuff. Which is why we always go and make sure that we change the oil filter, we change the strainer, and we change the nozzle. Because those are going to be my three most biggest culprits in my oil delivery system that's going to create an issue for my pump. Okay? If I have a clogged oil filter and a clogged strainer, I'm not going to be able to deliver the oil to my pump, which will in turn ruin the gears in my pump because I'm using the gears to not only deliver my oil pressure, but I'm also using the oil to lubricate the gears inside there. So I have to look, investigate. You're the detective. Most of the time, and I'm going to say this, any real mechanical issue that you are going to run into in a oil-fired piece of equipment is going to be your oil delivery line and system. That's the 90% of the time. It's either going to be an air leak, it's going to be a clogged oil line, filter, strainer, defective nozzle. Something like that is going to affect your nozzle in your delivery system. Okay? Questions?
If you have a problem in the delivery system, like you said, that will most likely cut the primary off, right? So we'll go on lockout?
It can, and sometimes it may not. I mean, you could think about, you can have issues, I guess, with your oil line where it may fire. Like, here you go, you have that intermittent problem, right?
Yeah.
Where it will fire, and it runs. It'll run through the entire cycle, is perfectly fine. But then on that next call for heat or whatever, it locks out because of, maybe lack of oil for whatever the hell reason. So you can have, a safety timing. You can lock out, and then there's other times maybe it will, it won't. So usually, like when you have those types of problems, you're going to do a full-fledged maintenance on that oil burner. You're going to change everything. You're going to change the filter. You're going to blow out the oil line, make sure that it's clear. You're going to change the strainer, gasket, nozzle. You're going to make sure that you have a clean flow of oil from the beginning to end. Then you're going to now attack the electrodes and, the wiring and all that stuff to make sure that it's intact. You're going to look at the CAD cell, make sure the CAD cell is working the way it's supposed to, make sure the air tube is clean, retention head's clean, all that stuff is clean. All right? Once that's all done and you fire, it should work. I mean, air, fuel, and spark, that's all you need in order for this thing to work properly.
Gotcha.
You understand?
Gotcha.
That's the big key to oil, guys, is cleanliness. It has to be clean. If it's not clean, it's going to mess up on you. Any other questions?
Crickets.
Crickets. I like it.
Will this PowerPoint be available on
I'll send it to you guys in an email. I'll send it to you guys all in the email. Yep.
My email was not been working. I've been trying several times. I haven't got your email yet.
You might have to go into your settings and put in your email password again. I know some guys have had that problem.
I didn't even get the mechanical course in my link until yesterday when I was going to go on the, I'm the York student and I go with my professor and I talk to you about. And one of my friend was Scott. He just sent me the link. And I was downloaded and I do the homeworks and everything, but I have a lot of things to be behind, so I have to complete that, like my quiz and my homework. So I did yesterday, but still I get a penalty, like I get a 60-point lose or everything like that. So
Okay.
Mr. Saccavino, he's in my class, and he started when I started, and he's had a problem with emails from day one. He's visited IT multiple times, and they just don't seem to be able to figure the problem out.
I'm the worst person to ask because, I mean, I know some of my guys had to go and put in their email password again in their settings. Like you go to settings and then I think accounts or something like that, and then you gotta put in the porter and your email password again because it, for some reason it just doesn't link or something like that. On my end, I can't help on that. I don't know how to even go about fixing it.
Yeah, because I did the homeworks and the quiz yesterday, and I get a graded, but I get a graded is only for 30 because of the time, because that was a past due, and I don't even have a course downloaded yet. So,
well, I will look into it. I will do something about the grade. But as far as email and all that stuff, you're going to have to either go to your director of education and fix it, or reach back out to IT. I don't know. I can't help you.
Okay. Thank you.
Okay. Any other questions?
Nope.
All right. If you have no other questions, guys, have a great day.
We do not have a quiz this week?
You will have a... I didn't open it.
Homework? No.
Did I open up the quiz?
No.
I don't think there was a quiz. Homework.
I think we do. I think we do. Oh, I got to open it. I'm sorry. I apologize. I think we do. Let me see. We did week 1 quiz, homework, right? All that crap.
Yeah, I think the homework is due tomorrow, I think.
Homework is due tomorrow. Quiz week 1. We did week 1 quiz. We did 2. Okay, yep, here we go. Alright, hold on. I'm getting there. Hold on.
I mean, I'm not asking for a quiz. I just don't want one to pop up. I don't know. I don't want to wake up tomorrow and be like, oh, crap, there's a quiz.
All right, so we'll do it today, and then we'll close it tomorrow. All right, so... All right. Okay, there you go. It's open now.
Is that just for Stratford, though? Because I think the guy talking, I think, is from New York. So I don't know, like, how...
Yeah, I did it for everybody. I just did it for everybody. It opens it's open today, and it doesn't close until midnight tomorrow.
Cool.
Good to know.
Okay. So you guys can take care of that at some point between, now and midnight tomorrow. And you should be all set. Guys in Stratford, obviously I will see you all tomorrow.
Yeah, what do we get to break tomorrow, by the way?
What do we get to break tomorrow? Oh, I don't know yet. I haven't figured that out, but I'll let you know when I get there.
Cool.
We'll break something. Maybe we'll start messing around with some boilers.
Is practical pretty much dead for the previous course for the electrical?
No, we're still doing it, but I haven't come up with a date yet to get it done. But I can guarantee you it's probably going to be in the very near future.
Okay.
So be prepared.
Yep.
Okay.
Alrighty.
So other than that, guys, if you have nothing else, have a great rest of your Thursday. And have fun.
See ya.
See ya.
Peace. Break.